Hello, everybody. Happy Tuesday. Hope you're doing all right. Alrighty. We made it. It is March, officially. And is that 2 more weeks now till spring officially starts? Hey, Lemon. So we had the midterm and break, and then the midterm was due today by 6 p.m. I think most people got it in. Let's see. 15 people. Out of how many are in the class? I don't actually remember. Let me see. Let me get logged in here and see how many people are in the class. How do I do that? Let me do that on the other screen real quick. I don't remember what pops up here. Oh, there we go. Sure. That's easy. So, winter, we have... For the Tuesday night class, 25 minus 8. That puts us at 17, right? So 17 out of 15. I think that's most people then. Got it in. Yeah. Okay, cool. Hopefully that's going okay for you folks. And it wasn't too bad. Pretty much in line with the practice. And do you want to go over the long answer questions for that? Or what do you think? We can do either. So we've got that tonight, and we also have, we'll talk about, not my email. We're not talking about my email. We have the next project to talk about tonight. So this will be our project 3, I believe. Yep, project 3 tonight, and then we have chapter 8. We're not going to do all of chapter 8. We're going to touch on enough of chapter 8 so that when we do Java FX stuff, it makes sense. Because we need to know some basics of inheritance. Right? This demonstrate the core concepts of inheritance. So we just need some core concepts here for inheritance. We don't need anything super advanced when we get to inheritance here. So what do you think? Ooh, D2L changed their little favicon. That's fun. So do you want to go over the midterm right now, or is it not interesting? We'll jump into new stuff. Do we have... I don't think we had any outstanding labs, right? I think those were all turned in. Yeah, we did our labs on classes, and we're done with that one. We got through those. I have gotten nothing graded. I apologize. Ever since the Russian conflict in Ukraine started, I've been a real hot mess. So 2 of my kids are Ukrainian. We adopted them 6 years ago? Yeah, I think 6 years ago now. Really? 7. 6. 6 years ago, I think. I should probably know what year it was. But we've got friends over there, and I lost a friend last Sunday, and I did just about nothing all of that week. So there was a couple things I really had to do, other administrative tasks that had to get done, but other than that, I was just a mess, and still not doing great, but, you know, we're getting there. Things have to continue, I suppose. So we'll keep going, and we'll see what's up from there. So what do you folks want to do first? We'll talk about inheritance, and then the lab, and then the project. That sound like fun? Definitely. First, the caffeine. This is like one of my favorite mugs that I have. This one is from Marketplace. It's a great program on American public media. Definitely highly recommend them. All right. Sorry, what, Sarah? Yes to which one? To starting inheritance and then the lab and then the project? We'll worry about the midterm another time, or not any super big burning questions about it, because I think they're pretty similar to the practice ones. That was the goal. No big surprises was the goal there. Okay. Yeah, so let's start on inheritance. I should have fired up NetBeans while we're talking. Had a lot of coffee today. I'm compensating. So try and take some deep breaths and slow down a second. See how it goes. Let's see. I'll organize my office here a little bit. So hopefully you folks had a good break and classes are going well. summer registration is underway. Today is the last day of priority registration, if I remember that right. Let's see. I think it says it right here somewhere on the homepage. Or if we sign out, does it tell us right here at the login page? No. Usually they had some good info here. But yeah, summer classes are open for enrollment now. And so depending on, register. Here's the page. This is what I was looking for. The dates here for it. Where did it go? I think it must be in the calendar then. Yeah. So for summer, right, the priority registration days today and yesterday for people who had 30 or more credits, and then I think 15 or more credits or something like that. And then everyone else gets to start tomorrow. So if you have some credits under your belt, then you're going to want to register before everyone else does, if possible. I have that. Registration dates. That's not... I don't even remember what it is. There's somewhere in here that it says what those priorities are. Sorry about our website. Let's see if we can find it here. Registration. Placement testing, formats, registration tips, drop section deadlines. Why are there no priority? We'll just search it. Maybe the search works here. Priority registration. I've done this before for another class. So why it's in my search there. Registration FAQs. How could we not find our FAQ page before? Where was the FAQs from registration? You see FAQ? There we go, registration FAQs. There is a link to it. And then priority registration. That's where it is here. 30 more credits and have an active program. Ooh, 6 to 29. So you folks, I think, aren't eligible for it then? Or I'm not sure if they haven't counted classes that you are done with yet or not. But it should tell you when you go to the site. So do pick. There are less classes offered in the summer than fall and winter usually. So just keep that in mind when you're looking for classes here. We have, can we search for people registered already? Well, look at that. Well, that's exciting. I got 50% of classes. That's crazy. Yeah, so like this data structures class, is one of the last ones in our software program that you'll do. We already have 11 people signed up. No, wrong page there. Goodness. Okay. Oh, man. Okay, it didn't actually load anything. Is NetBeans still waiting to go? It's still waiting to go. Why is NetBeans being super slow? Give me just half a second here. Got to get off of this page here. Okay, I'm good. If I click the class, apparently it shows the roster, and I probably should not be showing a roster. Is that a good plan here? Let's go back home. So that's pretty cool. But search for sections, see what's up if you're interested in courses, and we can go from there. I lost the overlay. Uh-oh. Let me refresh it. There it goes. Now it came back. And it's gone again. I broke it, friends. I really broke it. Huh. I don't know what went wrong with it. That's super... Okay, now it's back again. I don't know what's going on, friends. Alright, so let's pull up where we left off with classes, because we're going to use classes as a springboard into inheritance. If this thing ever loads. It's not actually loaded here. Machines are fighting back. Yes. Yes, they are, Lynn. Oh, goodness. Okay, so let's open a project from our class repository. I'm going to find 1500 for Tuesday nights. And then we're going to look at classes. There we go. Excuse me. So, a couple things we did with classes. We had the can class, right? with private attributes, with public methods for getting and setting, if they're appropriate. Right? Remember, not every attribute needs a set method. If it should be set, great, go for it. Let them set it. If it shouldn't change once you create it, then don't let them change it when it gets created. Ways of interacting are public methods here. Like drink, it's awesome. I can free up 104 megabytes of disk space. That sounds fantastic. No wonder the thing is so slow. In our sets, we can also do some sanity checking, like protecting integrity of our class here, making sure you don't give me bad values. Very important. This is fundamental to object-oriented programming. So our classes this is how we talk about things, how we create instances of these classes that are called objects. Right? So every can that I make is an object. So this Coke is an object, an instance of the can class. So I have the instance of can class loaded in memory and has its own set of attributes for max volume in milliliters, current volume in milliliters, and the beverage that's inside the can. Right? And we could do some silly things, drink from our cans, and you can pass objects around as parameters, do lots of really fun stuff with them. So let's start chapter 8 on inheritance. Start a new Java with Ant, Java application. Chapter 8, inheritance. Oh, that's in the wrong folder. Shoot. Oh boy, let me try that again after this one's done. This is what I get for rushing through. Apparently I've had too much coffee today. Nope. Let's get rid of this one. Delete. Delete. Try it again. Project, Java with Ant, Java application, put it in our GitHub directory so that way I can commit it to the right repo and you folks can find it later. Here we go, GitHub, winter 2022 on Tuesday nights. Here's chapter 8, inheritance. All right, now we can go make some classes. This was chapter 8, right? I think that was what we had said. Yeah, chapter 8, good. Good. So let's start with a basic class here. So let's say we wanted to have a way to represent some shapes, particularly polygons, because polygons are fun, right? You know, a polygon is just a shape with some number of sides. So I'm going to go to my project, right? Chapter 8 inheritance, open up source packages, find my package, right-click on it, and say new Java class. We'll call this polygon. Oh shoot, we haven't done arrays and collection. Oh my goodness. Friends, I can't do my polygon example. Forget polygon. We haven't done that yet. I am confused. Let's try another class. Let's do a item class. I like item. So an item is something that we're going to sell. So when we think about items for sale, right, we have some private attributes. We probably have a string for the name. We probably have a string for the, was that the barcode or the UPC or the SKU? I think they call them SKUs, right? Is that the barcode on it? Right, so for a given like can of Perrier here, I've got this lovely SKU or barcode or whatever you want to call that. I don't know the difference between them here. If I can get it to focus, maybe. Focus? Maybe. So it starts with a 0. So anything that starts with a 0 is probably going to cause some problems if you want to store it numerically, because we don't have leading zeros inside of numbers. And it is larger than 2 billion as well. Right? There are 12 digits in this. So I get 3, and then 6 in thousands, 9 in millions, and then 10 becomes the first billion. So we wouldn't even be able to store it as an integer either. But I think a string is probably fine for SKU here. And then probably have a double for price. So you have a name, you have a SKU, you have a price for these items that we want to sell. Okay? Now, remember, we are big fans of the tool doing the work for us here. So what I want to do is I want to have get values for all of these things. But once I put an item on the shelf, right, the name is probably not going to change, and the barcode for sure is not going to change. So I don't want set values for name and SKU. I don't want to give you the ability to change that. Now, the price can change, right? That's definitely something that happens. If we put an item on sale, we need to change the price. When it goes off of sale, we need to jack the price back up. When there is fear around uncertainty in the global political climate and all sorts of supply chain issues, we can also jack the price up and start gouging people, right? So definitely price should be able to be changeable, but SKU and name should not. So what I'm going to do, I'm going to go right click and insert code. So I'm going to add get methods for all of them here. I want all of them to have gets, so you can get the current value back out. Well, I get methods, and then I only want a set for price. So I'm going to insert a setter method only for price, because that's the only one that should change. And we also should do some sanity checking. We should say, hey, if the price is greater than 0, price is greater than 0, then we take the price. Right? Otherwise, well, I don't know. I mean, if it's... What's our else here? If they gave us negative, do we just set it to 0? I guess we can. Sure. No, else. This dot price is 0, I guess. No, not price dot price. This dot price. Friends, I can't type tonight. So at least we won't go negative. I guess we can give it away for free. Like throw it on the whatever free shelf for people. We're gonna get rid of it here. But do that sanity checking, right? Protect the integrity of our class. Now we need a constructor. We need a way to make an instance of this where we provide a name and SKU. So I'm going to right-click Insert Code and say Constructor. And I want name and SKU. And maybe we get a price as well. Well, we'll include the price anyway. Why not? So I'll say, okay, you give me a name, SKU, and price. And now I don't want to do this set price here, or this price equals price. I want to use my own set price method that will do that sanity checking for me. Right? Because we already did the logic once to make sure it's positive to take the price. Okay? So now, when you create an instance of item, the name and SKU are provided, and they can't be changed. There is no set method for those things here. Okay? There isn't, it's not available. And what else? So if this is an item that we're selling, what if we also had quantity, maybe? How about we had quantity? So let's add another. We'll add a private int for quantity. And sure, so we need a way to go update these. So let's take an int for quantity, and then we'll have this.quantity equals the quantity. And now quantity should change, right? You can change the number of items that you have on your shelf, for sure. Quantity? Why is that? It's still highlighted funny. That's all right, it is red. I think it's just confused. So we'll add a set and get then for quantity. So I'm going to insert a setter and getter, this time for quantity. And I'll have a get quantity and a set quantity. Again, we should sanity check this. We can say, hey, if the quantity is greater than 0, sure, go do this thing. Otherwise, we'll take our this.quantity and set it to 0. So if you give me an invalid value, I'll just set it to 0. Otherwise, I have a quantity. Okay? This is this particular item. So maybe I want to say I want to buy 10 of Perrier bottles. Here's the SKU for it, and the price. This should probably be, unit price maybe. Maybe that might be better than price instead of just price. Let's try that. So let me do refactor rename. So don't just rename it yourself. Use the tool here. So we'll call this unit price. Here. And it updates it everywhere. So now I have, it didn't update it here. Bummer. Unit price. It's unit price, but now we get a set unit price and a get unit price. So it's pretty smart. It does a pretty good job with those everywhere here. Okay, so far we haven't done anything new from Chapter 7. Right? All we did was write a class here. The other thing we want to do now is be able to get a total price. So let's write a double get total price, which is going to return my unit price times the quantity. So if you're buying 10 something and they cost $1.50 each, right, you're going to pay $15. Does that part make sense so far? So then in the section with main here, we can go make some items, right? So, and we can even ask these, I guess. So we'll make a scanner. Well, keyboard is a new scanner, given system.in. And then we can ask them, hey, what do you want to sell? Do you want to sell, or I guess buy, right? We'll say buy because we're telling them how much it costs. And we got to enter import. Excuse me. Then we'll have our string for name is my keyboard.nextLine. And then we'll ask them what is the SKU. And we'll have a string for SKU is the keyboard.nextLine. And then we'll ask them what's the price is the unit price. And we'll have a double for unit price given double.parseDouble of the keyboard.nextLine. And then we'll ask for how many. How many are you buying? And then we'll have an int for quantity is integer.parseInt of the keyboard.nextLine. Okay, so all those prompts here happening, again, in main. The class should have nothing to do with system.out.println and using scanner to get input. Right? It shouldn't print anything, and it shouldn't ask for any values. All those are passed by parameters to the public methods that we write. But the idea of the class is encapsulated. We're taking all the details, encapsulating them up into one nice little package here, and we give someone an abstract way of interacting with us. We give them public methods that will do the thing we said that they do. They don't need to know the details. They just need to know, hey, we'll set quantity or we'll set unit price. We'll do these things here. We'll give you the total price. Whatever methods we're writing, right? They're going to interact with our application programming interface, our API, our public methods. Okay, so then I can actually make an item. So then I can say item, item equal the new item, and I can give it the name, the SKU, the price, and the quantity. Now, these variable names don't have to match. There's nothing that says because I said the parameter name is name, that you have to give me a variable called name, right? I could give it ABC, right? As long as it's a string, it doesn't care what it is. I'm just using that same parameter name because that is what it is, right? It represents that object. So you can tell them it will cost you, and maybe the $ plus item dot get total price, right? We can get total price. Okay, we'll get the total price out from the item. We'll ask the item, okay, how much does it cost? Let's give it a run, see if it works here. So let's buy some coffee. Its SKU is 1, 2, 3. I don't know, it is $1.99 each, and let's buy a dozen of them here. Didn't do it. This is the compile and save thing. Like, it almost all finished, except for that last little bit there. Well, now, see if it actually compiles. Get a little more coffee while it thinks. Excuse me. Let's buy some coffee. SKU is 1, 2, 3. Unit price is $1.99. Let's buy a dozen of them. All right, 12 times $1.99. I think that checks out, right? 12 cents less than 2 times 24, right? $23.88. Costs a lot if you drink a lot of coffee, doesn't it? All right, so now we have item. Fantastic. You haven't done anything new yet. You ready for the new stuff? So, one of the fundamentals of object-oriented programming, we've talked about encapsulation and abstraction. Another is inheritance. Inheritance lets you create an is-a relationship, essentially a parent, a child relationship, where you are a type of your parent class, but you're a special version of it here. So we can make something. So because my class item is so amazing, we use it in so many different locations, I don't want to go change item necessarily because it's already done and written, and I might not need these new features. So what I can do is I can inherit from item, I can become an item, and then make a special version of it here. So we're going to add a new class. Let's call this a taxable item. So if you're a taxable item, we're going to use a new special keyword here called extends. We say we extends item. This is what creates the inheritance. Inheritance with extends keyword. Keyword. Right? That's our keyword here. Extends. Now, right off the bat, it's upset with me. It's saying constructor item in class item cannot be applied to the given types. Required string double int. Found no arguments. Remember, when you write a class in Java here, there is the no argument constructor or a default constructor that takes no arguments that Java will give to you if you don't write one. But it's always good to write one. Always good practice to write one. Or you can write a constructor that takes parameters. What's happening here is item has a constructor that takes parameters, and taxable item isn't using it. So you can't be an item without this item constructor running. So if we don't have a no argument constructor, we have to call it here. So what we need to do is we need to write our own constructor here. So we can actually, this add constructor does it for us, essentially. And we're going to change a couple things, but it makes a constructor for us called taxable item that accepts all of the values that our parent class needs. So there's a couple terms for inheritance, or a couple ways of describing the parent class and the child class. Parent and child is not really actually the best relation, the best way to describe it, because it's a little bit different than that. That one's common, but I thought our technical term here is superclass and subclass. So item is our superclass, parent class, or possibly the base class. So superclass, parent class, base class. And then this now, taxable item, is the subclass or child class or base and derived class. So taxable item is a subclass, a child class, or a derived class. So any of those pairs essentially can be used interchangeably. I think super and subclass is probably the most common, especially because we use the keyword super. So super is a reserved word that says, hey, go to my superclass and do this thing. In this case, the superclass, we're doing the constructor. Saying go do the superclass constructor, give it the name, SKU, unit price, and quantity that you were given in your constructor here. Now, what we also need, as a taxable item, we need a double for the tax rate. So we need another private attribute. So we need a private double for tax rate here. And tax rate is probably changeable. So I'm going to add then, I'm going to go to insert code and add getters and setters for tax rate. And my set tax rate, again, should do some sanity checking. If my tax rate is less than 0, I'm sorry, greater than 0, we'll do the thing, right? We'll accept this one here. Otherwise, we'll say our tax rate is 0, if you don't tell me otherwise. So we can do a little bit of sanity checking, and we should call our set tax rate function, our method here, given the tax rate. Excuse me. So now what's really cool, back in our code here, you can make a taxable item. We'll call this a taxable item equal to new taxable item, and we'll give it. I don't know. Is coffee taxable? Some food items are not, but prepared foods are. So sure, we'll just do the whole same thing, and then we'll say, hey, this is a 0.06% sales tax for Michigan sales tax. Or maybe we could ask people, what is the tax rate? Sales tax rate. And we're going to say between 0 and 1. Right? So like 0.06 is 6%. If you say 6 as a whole number, that probably means 600%. Right? When you deal with percents, they're actually decimal places. Thanks, math class. So we'll have a double for tax rate is double.parseDouble of the keyboard.next line. We'll grab that, and we can pass it the tax rate. Okay. Now what's really cool here, the only methods I wrote are get tax rate and set tax rate. But when I come back to my class here and I have a taxable item, I put taxable item, and I say dot. Notice we get a bunch of other methods. We have a get SKU, a get quantity, a get total price, a get unit price, a set quantity, a set unit price. All of these methods here are coming from my superclass. when you use inheritance, you create you are a type of your parent class, but you have additional functionality. You're a special version of it. So you can do all of the public methods of your parent class, of your superclass, of your base class. Then we can specialize. We can add new features here, like get tax rate, right? But I want to get total price, right? Get total price. Let's see, get total price. Let's do that here. With the taxable item, yeah, to get total price. Okay, so let's give this a run real quick. So let's buy some coffee. Let's SKUs 1, 2, 3. Why not? The unit price of $1.99. Let's buy 12 of them. And then the tax rate is 0.06. Uh-oh, we didn't account for the tax rate. Get total price here in the item class has no idea what the tax rate is. It can't do that. Well, here's where we can specialize it. So what we can do then, we can say, well, I want to do that same thing my parent class does, but I want to change the behavior. So our keyword for change the behavior is this at override. It's called overriding a method here. So the at override is not technically required. This is considered an annotation. This is telling Java that I want to change something my parent class does. I want to do a special thing instead of what the parent class does. So it just helps make sure we do the right thing here. So I'm going to write a method public double get total price. Total price here. And now for now I'm just going to say return 0 for a second. I want to show you. So with the at override, it's making sure this is good, right? But if I were to typo this and like get total price with an O here, T capital O, the method's name is not the same, and it says method does not override or implement a method from a supertype. So you get this checking automatically by using this annotation to make sure you didn't typo get total price. Because get total price with a capital O is not the same method as get total price with a lowercase o. Remember, Java is very case sensitive here. So it's very helpful to have that. So what we want to do, well, I want to get the unit price and the quantity and then add the sales tax to it. So I have two options. One, I can go use the public methods, get quantity and get unit price, and do my own multiplication. Or I can ask my superclass to do its version. So I'm going to say superclass, super dot, get total price. So this says, hey, do the superclass version of get total price plus, we're going to return all this. Let's do times 1 plus the tax rate. How about that? So let's get the total price from my superclass, which is just quantity times unit price, and let's multiply it by 1 plus the tax rate. If I gave you 0.06 for the tax rate, 1 plus 0.06, I'll multiply by 1.06, I'll add 6% for taxes, right, with my get total price. Now what's super cool here, that this still runs, my taxable item.get total price. We can run this here. Now it should add the tax, because we have a special version. We have an overridden method that changes the behavior of the parent class. So it's coffee, SKUs 1, 2, 3, for the $1.99. Let's buy a dozen of them here. And the sales tax rate, 0.06. So then with sales tax, we're paying $25, 31.28 cents. We should clean this up, but it's not going to matter too much right now. We don't care. I don't care about the fractions of pennies. It's okay. It's not the prettiest thing in the world, but it's not the worst thing either. So we are now using inheritance to create a special version of item. It does all of the things items does. It is an item, but it's a special version with additional functions, features, and functionality, and we can even change the behavior of the parent class. So instead of the regular get total price, it will do my version of get total price. All right. Now here's the next super cool thing here. I can write a method like public void print item, given an item, we'll just call item. And I'm just going to take this line here. Where do we do this here? It will cost you. I'm going to take this line out and say it will cost you, instead of it, how about we say item.getName, getName plus will cost you, I don't know, or how about to buy plus item.getQuantity, quantity plus of plus the item get name. Look at this. This is getting long and ugly. But we're going to say, hey, to buy this many of this thing will cost you this much. Right? So I can use my method here then to say, hey, let's print item given the item. Oh, public static void, sorry. Everything we call in main has to be static. Again, we're not going to get too much into that. That's more for next semester. Don't worry too much about it. So I can print an item given an item here, right? Again, use the method. Don't have to reinvent the wheel here. Now the super cool thing. This is my favorite thing here. There's an additional fundamental of object-oriented programming called polymorphism. It's not the D&D spell polymorph, or any sort of fantasy spell polymorph, but it's polymorphism. It's being able to treat one object as another. So because a taxable item is an item, we can treat it as an item. So I can call my print item method here, and I can give it the taxable item because it is an item. Inheritance, right? Taxable item is an item. You can treat it like it. Okay, so it will fit where we say, hey, I want a method that accepts an item. Well, taxable item is an item. Now the super cool thing, what polymorphism does is it says, okay, I'm actually a taxable item here, but I look like an item because I am an item. But when you call get total price at runtime, so while the program is running, when you call the get total price method, it will say, oh, this item is actually a taxable item and it has an overridden version of this method. Let's run the overridden version. Let's run the correct version, because while it's running, it says, oh, you're not really just an item, you're a special item, you're a taxable item. We'll run your version because you overrode that behavior. So when this runs here, we'll watch that magic happen. And it's really magical. This is super cool that you can do this sort of thing. So this is coffee. SKUs 1, 2, 3. Unit price is $1.99. Let's buy 12 of them. So to buy 12 coffee will cost you $23.88. Tax rate is 0.06. Now to buy 12 coffee will cost you $25.38. But the method here only needed an item. So because of polymorphism, when we call get total price, it goes at runtime to the taxable items get total price. And you can put a breakpoint here, and you can watch it happen if we run this in debug mode. So debug mode is definitely your friend. Let's watch it in debug mode for a second here. Let's see, it's thinking about it. Okay, coffee, SKU 1, 2, 3, unit price $1.99, want to buy 12 of them. Here we go. So we're in the print item method here. So right now, item, then we can see this item variable is coffee, 1, 2, 3, $1.99, 12 of them. Sure. And if I step into, instead of step over, I'm going to step into the method here. I don't want print line, sorry, not that one. Where's my, here, I want, not the print line, I want the get quantity. I'm going to click on get quantity. There we go. So it's going to run to the get quantity. So now I see this. Remember, this is the current instance. I can see coffee, 1, 2, 3, $1.99, 12 is the this here. And then we'll step out. And we're back in here. It's going to print. We can step over. We can step into the get total price step. Right? Get total price returns unit price and quantity. Great. We'll step out. Step over. Now we're back to print item again. Let's see. So do we print out our item? No, we didn't finish that yet. So hang on, let's step out. There we go. Now we're back here. So let's print out, we're going to ask for it. So I'm going to hit continue here. Let's keep running until we get to the next breakpoint. So we'll ask for the sales tax here, 0.06. And now I'm back at print item. Right? I have a item here that is a taxable item is the type, not just item here. It has a tax rate, and then these inherited attributes are name, SKU, unit price, and quantity. So it shows me, hey, all these things I inherited from my parent class, my super class here, my base class, are right here. So then if I want to step into, I want to step into the get total price, it goes to the taxable item get total price. And this is that magic. Right? And in here then, we'll go to the super class version, the item version of get total price, take the value, multiply by 1 times the tax rate. So the this here is the taxable item, See all those inherited attributes? It's super cool. Inheritance is magic. And we get the correct version back out. Those are the basics of inheritance. So constructors are tricky because you have to call your superclass constructor if it doesn't have a default constructor. The superclass constructor, if it doesn't have a no argument / default constructor. Right, no argument or default, right? If you give it no arguments, that's the default constructor. Okay? Now, we're not done yet. We have other things we can do with this sort of class here. We can make more relationships here. So, taxable item is a special type of item. We can also add a new class here. That's for perishable item. Perishable items can't be sold after certain dates, right? Oops, I put it in the default package. That's not what I wanted. I'm going to drag it into the correct package. The default package is just messy. You don't want to deal with that. Okay, so perishable item then extends item. Okay, and it says, oh, you don't have your constructor. You're not calling it. So yeah, let's add the constructor here. Now, what does a perishable item need? It needs the string for expiration date, right? And then we'll have a set expiration date, or really probably just a private attribute here, private string for expiration date. And then we'll say this expiration date equals the expiration date that was given. And then I want a get method for expiration date. So let's insert our getter for expiration date here. And then we should have a way to figure out whether or not we've been expired. Dates are actually really hard. So there's actually a class here for date that you can use. Oh, we don't want to use date. What do we want to use instead? We want, oh goodness, is it date time? I think it's date time. Date time, the correct one? Java.time. Shoot. What is it? I don't know. Let's just go Google it. Java date. It's the date class. It said we shouldn't use date. Let's see. Yeah. That's weird. I guess we just use date. Sure, why not? Date. Ah, java.util.date, is that what it is? The utility library? Yeah, java.util.date, that's what it is. The Java utility date class here. Okay. And then we'll pass it a date here as the expiration date, and we'll have a get expiration date that returns the date. And then we're going to have another method here, a Boolean method for is expired, given a date for, actually, we'll just say is expired. So the date class here, I believe, has a date dot now, time dot now. Oh my goodness, there's a way to do it, and I'm sorry, I'm not remembering right now. Let's just go Google some more. Java date now. Yeah, date dot now. How do we get now? Current date and time. Stackabuse.com? That's what? A new date. Oh, a new date is the date. Okay, cool. So we're going to return, if it's expired, then new date is less than the expiration date. Is that going to work for us? Nope. Shoot. We can compare, right? New date dot. Ah, here we go. After or before. So if the new date is before the expiration date. So if the current date and time is before the expiration date, then we're going to return true. Okay, so you tell me when the item expires, right? And then we'll be able to figure out whether or not it is expired or not. Okay, so let's go make an item. So coffee does expire at some point. I mean, it gets stale. I don't know if it goes bad. As long as you haven't had moisture in it, it shouldn't mold, right? We do a pretty good job of those. We can make a perishable item. So let's do a perishable item. Let's call this our perishable item. Sure, equals a new perishable item. And let's give it the name, the SKU, everything here. And then when do we want it to expire? So how about we have it expire, let's do a new date given, and then what can we give? We got an import date here. Import java.util.date. Let's do a new date given, where's the date constructor? Date. So a couple ways that you can make instances of date here with the date constructors are you can give it an int for year, month, and day. Perfect. Your int for year, month, and day. Oh, that's fine. It's calendar.set. Oh, sure, whatever. It's fine. I'm sure we can make this work. So let's do 2022. Let's say 03, and how about 07? That'll be yesterday. We'll say it expired yesterday. Here. And then we can print out is expired given my perishable item dot is expired. And it should say, no, is expired. It should say true because the expiration date should be before the current date and time. See if it works. I don't know if it will or not. We'll find out. Buy coffee. Yeah, we're using this. It's warning us here that we shouldn't be using this deprecated. It's old. We shouldn't use it anymore, but it's fine. It's just for an example here. 12. Oh, 12. Oops. That's costing a lot. Oops. $12 of coffee and is expired is true. So what we could do then, we could say, hey, if we are expired, so public. Let's add an override. An override for get total price. So public double get total price. Let's say if is expired, we return 0. Otherwise, really, we can just return super.getTotalPrice. So if it's expired, we can't sell it, so we'll just say it's free. I know it doesn't exactly work like that, but we'll just pretend that we give away expired stuff because we would rather feed people than throw away food because we are not crazy. We're not greedy. I don't know what's the stores don't want to give away expired food because then they're afraid people won't pay for it, and then they're not going to make money. So they have to go and throw it out in the dumpster so that people won't go get it. I don't know. Maybe. I don't know how many people really would want the expired food, but I would rather have people make that decision themselves. But I don't run grocery stores, so I don't get to control that. And then we get to do the same print item here. So I can call print item given my perishable item, because perishable item is a type of item. It fits it through polymorphism here, and it should tell me it cost me $0 because it's expired, and I'm just going to get it for free. So I can take the old stale coffee for free, or I could pay for good fresh coffee. Let's buy coffee. SKUs 1, 2, 3, $1.99. Let's buy 12 of them. Sales tax 0.06. And then to buy expired coffee, right? Yeah. Sure. How you folks feeling? It's been about an hour now. So we write a class, and then we are going to extend that class through inheritance to create a special version of that class. And we're going to use inheritance later on. When we get to our JavaFX stuff, we use inheritance. So we need to get the basics of inheritance down. So next week we'll pick up arrays and collections, just the array list portion of that from chapter 12. And then the week after that we'll do file I/O and exceptions, a little deeper dive at exceptions. You really need them when we're working with file I/O. Otherwise bad stuff happens. We'll talk about project 3 tonight. We'll talk about the lab tonight. In 2 weeks we'll talk about the project 4. And then that one won't be due till April 5th, but I want to give you a whole month on that final project. So we'll propose the final project early. You folks, again, are welcome to pair up. I would encourage you to do that. Given we're still in the midst of a global pandemic, if you want to do it individually, I'm open to that as well. But I think you'll have a better experience if you pair up with somebody. So I can set up like a forum in here if you want to just limit it to people who have access to D2L and that sort of thing, because I know we've got randos on Discord and whatnot. So sure, we got some options. All right, so why don't we take a 10-minute break? We'll come back, we'll talk about some lab for some practice, and answer any other questions you have, and we'll talk about the next project, and we can go from there, okay? All right, let me put some music back on for you folks. And let's take 10. I think that puts us back to, is that 7:06, I think, p.m.? All right, folks, see you in a couple minutes. Hey everybody, welcome on back. Wow, that flew by. Sweet. Alright, so we got a couple things now to talk about then. So we need to work on our lab first for a little practice with inheritance here, and then we'll talk about project 3, which is a little bit more, right, diving into classes here. And we should be able to go from there, okay? So let me fire up a GitHub Classroom link for you, so we can make a new repository. Let's see. So we are moving into, this is lab number 7 here. So lab 7. As we do next week, on the 15th, before class starts. 10 points here for the lab. In the lab category, you'll turn in the URL for me. Lab 7, copy that link. There we go. Submit the feedback, pull request, URL. Okay. So we're going to write some classes here that will take advantage of inheritance for us. Right, so a lot of things, not everything, can use inheritance, but it makes sense for things that are similar and have shared attributes then. Right, so maybe we have, when you think of biology, you learn that there are all sorts of creatures, and a lot of creatures are all considered mammals. So mammal is like an upper level classification, right? You have the kingdom, phylum, class, order, family, genus, species. For some reason, that's still in my head. I don't know why from biology class, but that's one of the ways we organize them. So I think, is it the kingdom of Mammalia, right? Order, phylum, no, kingdom, phylum, class. No, is it class? Mammalia. Class or something like that? Let me see. What is it? We'll find out what it is. Yeah, within the class Mammalia. So that is the class. So kingdom, phylum, class, Mammalia. Sure. Right? Of all the things that we have in common, right? So mammals are all warm-blooded. They give birth to young ones, and all sorts of things that mammals have in common. Now, different species then within that are separate. Right, so a dog is not the same as a cat. They're both mammals, but they're different types of mammals. So, like, mammal could be considered that superclass, and then a subclass, right? The things that they have unique and distinct then go from there. So it's really good at building out these sort of hierarchies of relationships here, where we have a common set of attributes, and then you have your special versions of them. So let's see. So that's one way. We could kind of, see that sort of hierarchy there. And then another way, maybe, let's see, so we're going to write a class for book here that has attributes for author, or authors, right? Plural, possibly. So just make it like a string here for author as a string. Don't worry about it being like multiple. You just throw them all in one string. That's not too big of a deal there. We'll have a number of pages. We'll have a date published. As a string is fine. Don't worry about using like an actual date class or anything if you don't want to. Not a big deal there. A publisher. Right. I think that's probably it for book here. Right. So the author, the date published, the publisher. Number of pages, I think that should be fine, right? Then we're going to extend that class. We're going to write subclasses for an ebook here, which adds attribute. So the ebook then will have a separate attribute of the what we want to track: font size, current page. Sure, it doesn't have to be anything super interesting. Right, so like when you're reading on a Kindle, it tracks where you are. You don't even have to use a bookmark. You could do that sort of thing in a book, but that's fine. It knows what page you're on and what the font size is and that sort of thing, so which is really nice. And then we're going to write a subclass for audiobook, which adds attributes for narrator. Is it narrator or voice actor? Voice actors, possibly, as a string. And how about an int, I don't know, what sort of value do we want for int, length in seconds? I don't know, or duration, we'll just say a duration. Total duration. Duration as a string is fine. Right? So, I mean, some number of hours, some number of minutes, don't worry too much about it, just store it as a string. We don't care too much there. And then what we want to do is we want to have a method for getInfo, which returns a string value of all the attributes. Like this is, the book should also have a name for title. Right, the authors, so like, here's the title, authors, author, number of pages, date published, and publisher. Right, just include all those things as a string here. Like we're going to return a big long string for that. So in each of these subclasses, then we want to override the getInfo method to include the new attributes. Okay, so we're going to do that for both of those subclasses here. That's all we need to do. Nothing too fancy right now. So that should be it for our lab practice. Okay. So that getInfo, then when we override it, we're going to do the same thing my superclass does. And then in addition, we're going to add new values here, like what the current font size is, what current page we're on, or who the narrator, voice actors are, and the total duration, that sort of thing. Does that make sense? What we're going to try and tackle for lab here? Just a quick chance to practice some inheritance here, using books and then ebooks and audiobooks being special types of book then. We should add that in the title here. Lab set for inheritance. Okay. How's that sound? Is that good practice? Okay, cool. All right, and then we need project 3 here now. So we add a new assignment. Enter 2022, project 3. Using our college template. Our feedback pull requests, awesome. All right, and then we'll add a new project here. Project 3 is, I got to add some points here in a minute. Here, let's add a new project 3 in projects here. Please submit the feedback pull request and a self-assessment using the rubric here. That's the project text submission. Give me like a couple minutes. All right. All right. So I'll build that rubric out in a little bit here. How many points? Let me see how many points he's allowed for. So this is going to be worth more points than the previous projects because we're using all the things from the previous projects. What do we have here? Oh, buddy. Let me check the other screen real quick. I want to go to grade and see what the scores are, but I want to show everyone's stuff. Let's see. Okay, it was 10 points and then 11 points. Is that right? 14 points, right? 10 points, 14 points. So this will probably be, 16, 17, 18 points or so. Let's go back to that here. Bring that to this one. Probably about 18 points or so, I think, is probably pretty good here. Okay. And let's do this. Oh boy, where did it go here? Sorry, I'm on the wrong screen again. Looking at the wrong thing. All right, so we want to, where did that go? Sorry, I've got a thing I wanted to copy over here. Just a minute, please. Where did it go here? Maybe I can find it. Yeah, here we go. There's another topic we got to talk about here. Okay, that's what it is. That's what I was missing. So we're going to write a class for plane here. We're going to have attributes for make, model, number, max altitude in meters, current altitude in meters, a boolean for landing gear enabled. True means yes, false means no. We're going to have get methods for all of our attributes. We're going to include methods to enable or disable the landing gear. So it can be enable landing gear and disable landing gear, or it can be a method set landing gear to, or true or false. Any way you want to go about that is fine, one or the other. But if the plane's current altitude is above 100, don't let it get turned on. If the current altitude is below 100, don't let it get turned off. So at 100, the landing gear can be disabled. Right, 100 or more, it can be disabled. We're going to have a method for change altitude, which accepts the numbers of meters to change. Positive for increasing our altitude, negative for decreasing our altitude. We don't want to go above 100 meters if our landing gear is enabled. So we're sort of doing a little sanity check here. If you try and take the plane too high and the landing gear is still on, we're going to stop at 100 meters. If we're up high and we're descending, we're not going to be able to go below 100 meters if the landing gear is not enabled, if it's disabled. The plane can't go above max altitude, and it can't go below 0. I know it's not actually proper because there are places that are below sea level. We'll just pretend that doesn't happen. Okay, so altitude of 0 is sea level, ground level. Just pretend the world is perfectly flat. Just pretend, please don't quote that. We're just pretending here for this altitude purposes here. We're going to return a Boolean result if the call was successful, or in a false if it was unsuccessful. Thanks, Bananas. And, I'm afraid that, oh man, that's going to get... We're just pretending. We're pretending it's flat. Okay. Then the other thing we need to talk about is unit tests and what a unit test is. This idea of 100% code coverage. I don't think we got to that with classes last week. So unit testing is the way of essentially doing what we did here, where I'm going to go print something out and I'm going to look at it and say, hey, did it include the right value? Did it take the quantity times the price and show me what I was expecting here? What we're going to do with unit tests is we're going to make the computer do it for us, because the computer is much better at comparing two values and seeing if they match. Right? When you write an English paper, you know what you meant to say, so when you go to proofread it, you miss a lot of things because you're not actually all that focused on it. Like you'll miss some of the double words or misspellings because in your head you know what it's supposed to say. Same thing goes for us. Yeah, definitely unit testing is the way to go. So we're going to make the computer do the checking for us. Instead of having to print everything out in the main method here, we're going to make the computer do it. So we can write a unit test for our class here. So I'm going to go to item, I'm going to right click item and say navigate, go to test. This is the shortcut. There are other ways to do it, but this is the fast way. And I'm sorry, I forgot my wife needed me to help the little guy with something. Give me like 5 minutes, folks. He's being a little cranky, he needs some medicine. He's a little congested right now from his allergies. So I'll be right back in like 5 minutes and we'll talk about unit tests, okay? Just a second, I'm sorry. So that puts us out to 27 or so. Okay, I'll be right back. Hey, I'm back. Alright, sorry about that. Let's see. Oh wow, that was actually decently loud for being turned down already. Should have had that a little lower. Alright, so we want to write some unit tests to make the computer do the checking for us, right? The computer's going to see whether or not we are doing what we expect to do. So this idea of testing, right, is actually super helpful and useful because we want to make sure the code does what we expect it to do, and either we're going to do the checking or we're going to make the computer do the checking for us, and the computer is better at it than us. And there's all sorts of cool things we can do. So unit testing is the smallest level, the lowest level, like one unit at a time, essentially one method at a time here. That's going to work. So I'm going to go to Navigate, go to Test here, and it's going to say, hey, do you want to make some tests? Yes, we do. Now, this is the particular part. Because we're using Java with Ant, we need to make sure our framework is JUnit 4. Very important here. It doesn't work with the latest version for reasons. So JUnit 4 for our stuff here. We don't need any of the other boxes checked here. The access levels are fine. So those should be good. Okay, so JUnit 4 will make some tests, and then what it's going to do, it's going to add stuff to this test packages location here. And what's cool about test packages is if we were to actually take this code and bundle it all together and send it somewhere for someone to use and give them like a jar file, which is just a bunch of Java files inside that you can actually run, none of the test stuff is included. So it keeps it separate here and in a nice way where I don't have a main method that's going to run a bunch of test stuff that I have to go then comment out later or whatever. Okay, so we get a bunch of methods here that all have this @test annotation. This is telling Java it's a test here. So all the gets are not all that interesting for testing here. So like get total price, yes, but get quantity, not very interesting. Get name, get SKU, get unit price, not very interesting. I don't want to test them separately because I'm a little bit lazy, and it's kind of silly to do it all separate here. So what I'm going to do, I'm going to get rid of the unit price, SKU, name here. I'm going to get rid of those ones. I'm going to get rid of quantity, and I'm going to get rid of total price as well. So all of the gets are going to go away, and I'm going to add a single test here. I'm going to call public void test constructor. Because really, the way that we wrote this item class is they're all coming through the constructor anyway. If your class has separate things, fine. You know, you're not really testing the constructor. That's okay. But our class, the constructor, will set all of those values, and then I can go get those values back out and see if they got what I expected. So we're going to follow a convention here. This is the AAA convention or format. Convention or format for laying out tests here. We're going to arrange, which is setting up all the variables I need to test. We're going to act, which is calling the code. We are testing and getting actual values. And then we're going to assert. Did we get what we expected? Okay, so those are our three sections. We're going to arrange, we're going to act, and we're going to assert. So for arrange here, I'm going to have a string for an expected name is coffee. We're going to have a string for an expected SKU is 123. We're going to have a double for expected price. We'll say 1.5. I want to keep the math easy here. And int for expected quantity. Let's say 3 here. And then we'll have a double for expected total price. That should be 4.5. So I know if these are the values here, right, of coffee, 123, 1.5 for the unit price, and 3 for the quantity, the total price should be 4.5. I know that should be it here. Okay, now we're going to call the code we're testing. So these are the variables I need for testing here. Everything that I expect to get back out, I need as a variable. Now we're going to call the code. We're going to call that constructor. So item equals a new item, given the expected name. Nope, goodness. Expected name, given the SKU, given the price, and the quantity. Oh, hey there, almost. Oh, no, Java's fantastic. Nothing wrong with Java. Lots of other languages that are good too, but Java's fine. All right, so we give it the name, the SKU, the expected price, and the quantity. So this is the code we're testing. We're testing the constructor here. Now we need to go get what the item class says my values are. So I'm going to have a string for the actual name is my item.getName. We're going to use all those get methods. So this is essentially testing all of the gets at once, essentially here. So the actual name is item.getName. A string for actual SKU is the item.getSKU. A double for actual price is my item.getPrice. Or unit price, that's right. That's a double there. An int for actual quantity is my item.getQuantity. And then a double for actual total price is item.getTotalPrice. Okay, so we are testing this code, and then we're getting the values back out. Oh, thanks so much, Almost. I appreciate it, my friend. Glad to have you along here. All right, so we are calling the code we're testing. So in this case, it's a constructor. Later, we're going to test our setQuantity and setUnitPrice methods here because those have some additional logic we want to test. But for now, it's the constructor. And then did we get the values out that we're expecting? Because sometimes it's easy to put them in the wrong order, do the wrong things here. I mean, it auto-generated the code, so it should be fine here. But, you know, we're going to find out. We're going to see how well that works for us here. Oh, and I'm sorry, setQuantity should also be the method here. We shouldn't be setting here in case I give it a negative. Should use our method here. I like that. All right. So now we need to assert. So for assert, it's assert dot, or what is it? Assert equal. There we go. So assert equals the expected and the actual. So we give it pairs of the expected. So expected comes first, actual comes second. That's just the order in which this is done here. So I'm going to have a bunch of different asserts here then for name and SKU and price and quantity and total price. For SKU and SKU, the expected. So does the expected SKU match the actual SKU? Does the expected price match the actual price? Does the quantity, the expected quantity, match the actual quantity? does the total price. Actual. Why am I spelling things wrong? Actual. Does look wrong now. Actual. I can't spell, friends. I don't know if that's right or wrong now. That's okay. The expected total price match the actual total price. No, expected total price. Match the actual total price. Okay? So those are all the things we're checking. So the assert equals method will do that for us now. So what we can do now, I can right-click here and I can say run or test file, and it will run the test. So I'm going to get this really cool test view here in a second. Should in a second. Uh-oh. It failed. It's saying use assert equals actual, expected, and delta to compare floating point numbers. We did a bad thing here. So remember how Java's bad at arithmetic when it deals with decimal places? And sometimes you can get those like trailing millionths of things. So when you're comparing doubles, like actual price here, we need to give it, well, how close is close enough? So like let's say, hey, within a millionth here is close enough. So that's tenths, hundredths, thousandths, 10,000ths, 100,000ths. So if you're within a millionth here, I'm going to say you're close enough. So this is the delta only when dealing with doubles. How close is close enough? That's our delta. Let me put that over here, actually. Well, let's leave that here. So that's the delta here. Enough. So we also need that then for the total price, right? Okay, now I can run my test again. I can test file. And we're going to see that the tests pass. Now it says 3 tests pass. It says test set quantity, test constructor, and test unit price. Notice these ones are empty. So if it doesn't fail, it passes. So that is actually a little bit concerning. Like was it disconcerting? I don't remember the word. It's concerning because it's failing. So what you can do, you can assert fail. I think it's assert fail. I forget. There's a way to just fail it real quick. Fail. You can just fail the test here. Yeah, there we go. And this works because if you notice, oh no, we've imported. It's just coming from test. I thought this is not inheritance. I'm sorry. That's Python. We can just fail our tests here. So now when I run the tests, we get some red X's, we get some failures, which is nice. That's what we want to have happen. Maybe. Oh, fail. Where's my test? Oh goodness, where'd it go? That's not helpful. I don't want this ugliness here. Saying it failed. I want the nice little window. Windows. Where did it go? Alright, forget that then. Forget it. Not even worth it here. Forget it. We'll just let them pass here. I don't remember what that window was called. Where did it go? Test results. There it is. Test results. Now they failed. Okay, it just hit it in the tab here. There we go. So they failed. This one passes. So the goal is, right, my unit tests should pass. We know what the code's supposed to do. So we're going to make sure that it does what it's supposed to do. So if you want it to fail here, like if we gave it a negative price, right, this will fail now when I run my tests because we're not accepting a negative value, right? I know that that's happening. So the idea with unit tests, right, it says it expected negative 1.5 but was 0. So that if you give it the expected and then the actual, it even tells you in nice language here what happened at what line here, and you can actually go right to that line where it failed. The other fun thing is you can debug unit tests. You can put a breakpoint in, and then you can debug your tests. And you can step through step by step by step by step by step. Yeah, not implemented. Yeah. I'd rather not do more work. I'm going to go fix them here in a second. But yeah, I should probably not. I'm surprised it's not the default template. I probably just need to change my template. But this is testing the constructor here, right? So I'm going to put it back to 1.5. So if everything works normal, our constructor is great. So what's happening here, one of the things that we do with unit tests is we come up with this metric called code coverage. And the idea with code coverage, there's actually tools you can use, and generally you have to pay for them, that will tell you how much of your code is actually running here when the tests are ran. The goal is 100% code coverage. We want every line of code to be run at some point when we're testing. And what that means is if I have an if-else block, I need to test that this block of code runs, and I need to test where this block of code runs. Because if I'm only testing that it does what it's supposed to do when I give it a good value, I don't actually know if I wrote the code properly to make sure that if I give it a negative value, I get back a 0. Right? So I don't have 100% code coverage unless I have two different tests. One that tests a good quantity and one that tests the bad quantity. Now, we're not going to pay for any of those tools. Don't worry about it here. So we're just going to eyeball this. So for our plane project here, the goal was 100% code coverage. Where did it go here? There it is. So if our method here, like change altitude, if you can't go above 100 meters because your landing gear is enabled, and you try to, you're going to get back a false because it didn't work. You had to stop at 100 meters, you had to stop at 0, you had to stop at max. Right? So if there's an if-else that's happening here, we know we're going to need different tests to be checking for those sorts of things here. So when we do test set quantity here, I actually need two different test quantities. So this is successful. And so I'm going to give them good good method names here, because the method name is what you're going to see when it fails real fast. So we're going to say doesn't accept negative. So we'll have a successful and a doesn't accept negative. So now we don't actually need all these other things showing up here. I'm still going to do this AAA format. I'm going to arrange, I'm going to act, and I'm going to assert. So the only thing I need for a test quantity being successful is an int for expected quantity. We'll say is 3. Why not? Right? And when we act now, so to call set quantity, I can actually do this separately. I know the constructor calls it specifically, so maybe I can use the constructor. That's sort of cheating here, but I'm not, I want to do this separate. So I'm just going to say, hey, here's an item equals a new item, given, I don't care what the name is, I don't care what the SKU is, so I'm just giving it empty values here. I don't care what the price is, and the quantity for now I'm just going to put at 0, I guess, for now. So I'm just giving it dummy values here, because I'm going to go change them. So dummy values, because I don't care what they are yet. Now when we act, we're going to go use that set quantity method. So I'm going to say item.setQuantity, and I'm going to say, no, it's not what I'm going to do. Set quantity here, and we'll give it the expected quantity. Then I'll say I need a new int for the actual quantity, is the item.getQuantity. So if I pass it a quantity, does it properly change it? Yeah, set quantities correctly, successful. Yeah, I like that. Yeah, we haven't got to exceptions yet, so we're not throwing anything right now. So we're just doesn't accept negative really sets it to 0. We haven't got to our exceptions chapter yet. We get into that. Where did that go? I don't have it right now. In a couple weeks, we get into that. This is just our intro class. Yeah, definitely good things with our testing. Okay, so if I don't care about the name and the SKU and the unit price, and I don't care about the total price, the only thing this unit test cares about is, does the set quantity method work? Right, we're taking one unit here out of this whole thing. We sort of cheated here. I mean, this probably would have been more proper with separate unit tests for gets. I think that's really tedious, and I don't really care. I'm going to put all my constructor tests together, all the gets with the constructor, because that's what the constructor does. Again, when you go out into the industry and you start writing code and writing unit tests and doing your stuff, if your organization and the people who sign your paycheck say do it a different way, generally you just smile and nod, because you're the new junior developer. We'll just follow along with what everyone else is doing because that's how they're doing it, right? If they tell you we don't write tests here, then I would probably have a problem with that, and definitely at least argue that any code that is worth writing and that you're going to pay me to write, you probably care if I did it correctly, and you probably care if it does the right thing here. And unit tests is one way that I can verify that my code does what you paid me to make it do, actually works. I lost that there somewhere. So, I mean, I will definitely argue that any code worth writing is worth testing. Because if you don't care if it doesn't work, then don't test it. But if you care if it works, then, I mean, yeah, we should test it. Unit tests are not the only way to do this sort of thing, but it's a nice, relatively quick way of doing this, which is really fun. And then we have these unit tests later on as our code gets maintained and changed and made by other people. So when you look at this software development lifecycle, most of the time of a software product is spent in maintenance mode, not the development time, because you want the code that you write to be so useful and practical and worthwhile that the business keeps on using it for years and years and years and years. And then maybe they want changes to it, but they don't want to throw the whole thing out. Hey Crow, how you doing? Good to have you along here. So I'm going to go copy paste my assert here, because I don't have to type it again. We'll assert the quantities match. So set quantity, given 3, it should actually change the quantity. So this should be successful here. So now I'm going to do another test here that it doesn't accept a negative value. So if I give it a negative, so my expected quantity will be 0. If I set quantity to like -3, it should stay at 0 here. Now, I didn't actually pass back a value, so maybe we change that. Maybe we say, let's have a Boolean here. This is not, we're doing this for practice here. So if we set it here, I'm going to return a true. And if we don't accept it, then we're going to return false here. So really, this else can go away here, because if you return, the method stops. Right, we're done. So the else becomes redundant. So this way, you can kind of use this as your example for these. So we're going to return that result. So I'm going to then also have in my act a Boolean for result. And now with Boolean, with true or falses, you don't need an expected true or false. You can just say assert true given the result. Or you could say, in this case, assert false. This would be assert false given the result. False. There we go, that one. Right? So because we expect it to tell me it didn't work here, that I got a false result and the quantity is still 0. In this case, then, we want a Boolean result is my set quantity, and then we'll assert true that the result variable is true. And now we'll run our tests. So we're testing both sections here of set quantity because we want to make sure we have 100% code coverage. We want to make sure this block runs and this block of code runs. And I see my tests are running here, and I get 4 tests passed. So set quantity successful passed, set quantity doesn't accept negative passes, constructor passes, unit price passes. And again, unit price is empty. We haven't done it yet. So maybe again we change this perhaps successful, and then we'll do another one here in a minute for when it's not successful. So we're going to do the same thing here. We're going to arrange, we're going to act, we're going to assert, because any code that's worth writing is worth testing here. So we'll have a double for expected unit price. We'll say 0. We'll make them all 0. We'll set unit price to 0, to -3. Sure. We'll have an actual unit price. Item.get unit price, expected, and actual unit price. That's a double here, right? Double for actual unit price. Now, I don't have this Boolean result, so just for now, forget that. So we have one example of it. I don't think we need to do it twice. But we could do the same thing if we wanted, right? Which is kind of nice. That's our code's way of telling you whether or not it worked. Right, so this is successful. So if we set it to 3, then, and we set it to 3, it should get back 3. Now I'm going to copy this whole test again for the unsuccessful version here. So we'll say this one doesn't accept negative. So we should expect it to be 0 if we give it a negative value, like -3, right? So we want the unit test separate, Crow, because the code, when it gets packaged up for deployment, will exclude test packages. Right? Assert fail, or like just exiting in the main block, can cause other sorts of issues. So in this case, it kind of depends on what your code is supposed to be doing. If you give me a bad quantity, I'm just going to assume it's 0 here. If it should just hard crash because you gave me a bad value for quantity, we have other options. We haven't gotten to those yet, but it's probably cleaner not to crash here. When we get to exceptions, we could throw an exception, like an illegal argument exception, and say, hey, you gave me a bad value. And that's the more proper way. We just haven't got there yet. So for now, we're just essentially quietly accepting it, or quietly failing it, and just saying, hey, I'm just going to give you 0. Yeah, so we only run the tests when we want the test code to run. All right, so let's see if these ones work here. So let's test our file. See if we can try and give it negative if we actually get out zeros. Our assert's going to fail here. We need the deltas. I forgot our deltas. So how close is close enough? 0, 0, 0, 0, 0, 1. Say one more time here for the other one. Okay. Now, so you can also go to the test explorer and run the tests from here too. You can run individual tests, right? Just one test again you can run. You got lots of fun options here with testing. It's fantastic. So now we see the tests pass. Okay, so this is what we're going to do with that project here with plane. So again, with this plane idea, our enable and disable landing gear methods should work if we're at the right number of meters. Right? If you're above 100, it cannot turn on. You can't engage the landing gear if you're up too high, probably because bad things will happen. Right? We're pretending we're building some plane autopilot software or something fancy like that, right? Yeah, definitely we'll get to that automated testing. We haven't got there yet, almost, but that's the next step. So once we have the computer writing tests, we can actually hook it up into GitHub or any sort of source control tool to run continuous integration testing, so that anytime code changes in the repository, the tests will run. And then we can start building up more tests. There's other levels of testing. You can do integration testing or system testing or end-to-end testing. That we can include in here. Oh, I forgot a due date, 2 weeks, 6 p.m. that you can add. So once you have good continuous integration testing, why did that work? There we go. Then you can feel pretty confident that your software works. And if you have solid integration testing working, continuous integration testing working, you can move to continuous deployment, where your code will automatically go update itself in your live deployment once a change is checked in, to make it so that your developers can make changes and very quickly get them out in the system. So I have friends who work at Khan Academy, which is a fantastic website, by the way. They're an amazing organization working on getting high-quality education out to the masses through the wonders of the internet. And one of the things they do is they have automated testing and continuous integration and deployment. So when they make a change to their website and their web software, it will automatically go through the tests. If the tests pass, it will automatically go deploy it to the live site, which is fantastic. So the turnaround time for how long it takes a developer to make a change, to add new features and functionalities to something, or to fix a bug, and to getting it fixed out into people's hands is like that. It's amazing. So that it's setting the stage for those sorts of things to happen. Again, we're not there yet. This is our first programming class. We don't really have anything interesting that we can even continuously deploy. But we're setting the stage so we have the tests. Okay, how you folks feeling? So we're going to do that for the project. We can talk more about it next week as well if you want another chance to talk about it. So that's our project here. So we need a rubric. Let me do that the last little bit here. So our rubric for this then, let me I forget. This is the weirdest thing. When I go to add rubric, it like blocks everything else, so I can't even see it, which is obnoxious. So this is for project 3. We're going to have just the 2 levels. Either you did it or you didn't do it here. So missing and complete. So we don't even need inheritance for any of this. We're just sticking to classes and testing here for right now. So let's do, this is going to be 18 points total. So if we do 3 points for 6 things. Hey, thanks so much for following along, my friend. Glad to have you here. So our plain class constructor accepts values and sets defaults. So for plain, right, we had certain attributes for plain. You had the make, the model, the number. You had the max altitude. You probably don't make a plane up in the air. So our current altitude should get a default, right? When you make a brand new plane, altitude. Come on, spell check, help me out here. Altitude. There we go. Altitude. Didn't do it. Altitude. Current altitude. should default to 0. Right? You can't make a plane and say you already exist up in the air. Right? Landing gear enabled is true. So your defaults then will be current altitude 0, landing gear enabled is true, but you'll take values for name, for model, and for make, right? And max altitude. Technically, that's probably related to the model, but don't worry about that. That's okay. So that's our plane constructor. So we're probably doing that here. We have get methods for all attributes here. 3 more points for that. We have a set or enable and disable landing gear method or methods. Right? If you want one method that is enable landing gear that you can give it a true or false value, sure. If you want an enable landing gear method that just tries to enable it, sure. It's perfectly fine. No big deal there. We're going to have a change altitude method. Change altitude method. So it returns a Boolean result. Is successful or not, right? So true is successful, false if it's not, and it does all the right things that it's supposed to do, limiting you to that 100-meter mark. Can't go above max, can't go below 0, all those sorts of things there. And then we have unit tests. Unit tests for, I think, was that all we had in there, right? So unit tests for the constructor. You know what? Let's do this. We'll do unit tests for the constructor, unit tests. So that's unit test really for the constructor. Unit tests for landing gear, enable, disable landing gear, and then let's do unit tests for change altitude. So we'll make a total of 21 points. So that way it kind of works out nice, I think. So overall score thing is silly. It's not an English paper. Okay, so 21 total points. So you get points for doing it, and then you get points for testing it. Okay, so the get methods, right, and the constructor, 6 points here. You get 6 more points for enable landing gear and change altitude, and then you get 9 more points for your unit tests. So let's do 21 total. I like that. Okay, so I'll save that. You should have access to it. And we should be in pretty good shape. So the unit test stuff was new. If you're getting confused about it, don't worry. We can do some more practice with that as we go. We can go from there. I will work on getting this stuff graded. I apologize. I'm way too far behind now and just had an awful break due to all the conflict stuff. But life must go on. So we will try and get back on track with that and get those up to date for you. I apologize for the delay on those. But let me know what I can do to help. Hopefully, because you did your self-assessment, you know how you did on it. You saw you got the points for achieving it. Most of the time, people get what they scored themselves. Right? It's generally rare that people give themselves points when they shouldn't, and generally rare that people don't give themselves points when they should have earned them. So you can generally assume you'll get your self-assessment score, unless you lied about it. That sort of thing. So, all right. Any other questions, thoughts, or concerns, my friends? What else is going on tonight? Anything else interesting? Let's see. What else is what's good in Twitch land here? Is anything fun going on? What can I do for you? Oh, thanks so much, Almost. I really appreciate it. That's awesome. It's been a lot of fun being here on Twitch instead of Zoom. I don't know. There's nothing wrong with Zoom, but you know, we've actually, our college is really nice, and we've taken the approach that it's silly to try and force people to turn on their cameras when we have, you know, no control over what their, you know, learning situation is remotely. And that's essentially an invasion of privacy. So thankfully we don't have a push for everyone must be there, must have their camera on, and yada, 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 because what's the point? Sure. So yeah, it's been a lot of fun, and it's an awesome community out here in Twitch as well. So a little shout out for my friends in the Knowledge Fellowship here. Just a bunch of people who like talking about the things that they know and sharing their knowledge. I can go check it out here. The Discord is more active than the little Google Doc here or their website. Lots of cool people doing all sorts of cool stuff that they're just happy to be on here and talk about stuff that they've learned. So we can go and hang out with another friend here in Twitch land if you want, or you can go just get working on the lab or the project here. I've got my friend Boyd doing some woodworking on his segmented mug project, which is really fun. We've got our friend Ashuri, who is a game designer by trade, but now she's a full-time content creator for reasons, but she's really fun, always interesting to talk to. Ominous is doing some woodworking. He's actually an ER nurse out in Florida, which is really, he's a lot of fun. We've got Paleontologizing, if you want to go learn about some dinosaurs, a friend of the Knowledge Fellowship there as well. Or just friends playing video games. Microsoft is on if you want to talk about .NET distributed tracing. So all sorts of fun options. We can go raid some friends. Yeah, so Twitch will record. So the old recordings don't stay around long. They only stay for about 45 days. But I export everything out to YouTube. So if you're really bored, yeah, feel free to go check out my YouTube channel. I put everything out there from all my classes as well. And I'll give you a free dad joke, my friend. I actually have a handy-dandy pack of them here. Why did the Invisible Man turn down the job offer? He just couldn't see himself doing it. You want to see some crafting? All right, let's go hang out with Boyd. He's doing some awesome work here. So Boyd's Custom Fab. I actually have bought a couple of his products. He's got some really cool stuff. So he is an engineer, or retired from his industry job engineering. When it becomes a parent, right? When does a joke become a dad joke? I love it. All right, so we're going to try and raid over to Boyd, hang out there. Yep. All right, friends, let me know what I can do to help. Don't forget study group tomorrow from 12 to 1. If you missed it today from 5 to 6. Definitely worth your time to go out and hit up study group with Mr. Tim. All right, folks, you take care, and I will see you around. Thanks for hanging out.